All right, so we'll start off with a definition. Okay, and what are we going to be defining? We're going to define what the unit circle is, okay? So the unit circle. Okay, the unit circle is a circle in the XY plane. Okay, so it's in the coordinate plane. Okay, with its center at the origin. So the center is at the coordinate 0, 0. That's the origin, and it's of radius 1. Okay, so the term unit in unit circle, that has to do with the radius being 1 unit. Okay. All right, so I have a picture of what the unit circle looks like. This will be better than anything that I could ever draw. So let's just look at this for a second. Right, so this is the unit circle, okay? So look, we have our good old XY plane, and the center of the circle is precisely at the origin. It's at the coordinate 0, 0, and it's of radius 1, okay? So it's hitting 1, 0, 0, 1, -1, 0, and 0, -1. So these 4 coordinates around the circle, they are on the circle, okay? So maybe I'll just kind of just do that. So that is on the circle. So 1, 0 is on the circle, 0, 1 is on the circle, -1, 0 is on the circle, and 0, -1 is on the circle, okay? All right, so that's the unit circle. So any questions about this? Okay, so we do have a nice theorem to go along with the unit circle, and it's gonna have to do with our cosine and sine functions. So here's the theorem.
Is there a reason as to why those 4 points are where the circle hits the mark? I mean, is there a reason why, or?
Yes, and that's exactly because the radius of the circle is 1. So that means the distance from the center point of the circle to the circle must be distance 1 all around.
Okay.
And the 4 points that are distance 1 from the unit circle are, from the origin, are these 4 points.
Okay.
Because they're of distance 1 from the origin. That's why they live on the unit circle.
Okay.
Okay, so here's the theorem, okay? So here we go. So if a point x comma y on the if a point xy on the unit circle corresponds to a central angle theta, then, okay, we have the following conclusion. Then we know that the x coordinate will actually be equal to cosine of theta, and the y coordinate will be actually equal to sine of theta. Okay? This is a very nice theorem, and it's going to allow us to further calculate some more trig values. Okay? So I'm going to just kind of show you guys what this means. What does it mean for a point to correspond to an angle theta? What does that mean? So let me try and clear this up. Okay. So here we have a little arc of the unit circle, okay? Right here. This is just the piece of the unit circle that's in the first quadrant. Now, put a point on the unit circle right here. This is x comma y. Now this point will determine some angle t. I wrote it as theta, that this picture has t. All you do is you just move angle t, you move out this distance from the positive x-axis so that you become in line with that point xy, okay? So this theorem is telling us that this x value of the xy pair will be precisely cosine of this angle that it makes. And the y value, the y coordinate, will be precisely sine of t, sine of this angle, all right? So that is this theorem, but in a picture, okay? All right, good. So now let's use the theorem and it will become a little more clear. So we're gonna use the theorem to calculate something right now.
Is t sine because of the opposite angle thing or no?
Is t, okay, so t is just this angle right here.
No, what I mean, like for the size, like is there a reason the x has to be cosine instead of sine?
Oh, right, because if the x coordinate is cosine of t,
Hmm.
then that means we traveled horizontally cosine of t units.
Okay.
It's like in the coordinate pair 1 comma 2, you have to travel horizontally to the right 1 and then up 2. Here you travel to the right cosine of t and up sine of t.
Oh.
Another way you could look at it is that we know that cosine of t is adjacent over hypotenuse. So yeah, so by definition, it will be cosine of t over 1, which is cosine of t. That's another way of looking at it. All right. Anyways, this will become much more clear when we just do this example, okay? So, example. So use the above theorem to find cosine of 90 degrees and sine of 90 degrees. Okay, so now we're extending our trig values. Now we're going to add 90 into the mix. Okay, so first let me just write something and then we'll go into it. So by the theorem, we need to make a 90-degree angle in standard position and see which point on the unit circle that is. Okay. Okay, so basically we need to travel 90 degrees in standard position in the xy plane and then see what coordinate we hit of the unit circle at 90 degrees. Okay, so I have a picture for this. So this is very nice here. Right. Okay, so here we go. So in this we went 90 degrees. Okay, so this is 90 degrees. I hope you guys agree. This angle t is 90 degrees. Now, what coordinate of the unit circle do we intercept here? What coordinate on the unit circle does this angle of 90 correspond to? Does someone see it? So what point on the unit circle are we landing on if we travel 90 degrees?
It would be 0, 1.
Yes, exactly. Here's our 90-degree angle. It's right here. And yes, we do hit 0, 1. Okay, good. So we're pretty much done now. So the coordinate is 0, 1. Okay, so here we go. Now we know by the theorem that x will be equal to cosine of 90 degrees. But what is x here? It's 0. Okay, so cosine of 90 is 0. This is by the theorem. So remember up here, we know that x is equal to cos theta and y is sine theta. We're doing theta to be 90 degrees here. So x is 0. Okay, now y, by the theorem, is sine of 90 degrees. Okay, and what's the y coordinate here? Well, it's 1. And there you go. So that's the takeaway. So here is the conclusion. I will box it right here. All right, so cosine, so we have thus concluded that cosine of 90 degrees is 0 and sine of 90 is 1. All right.
So let's say we wanted, oh wait, never mind, okay. I was just curious to see if we wanted to get like 180 degrees, would that ever become and be a thing?
Yeah, that's the next example, actually. Yes. Yeah, so it will be a thing because this theorem is valid for all angles. So yes, 180 degrees is definitely allowed to use in this theorem. So here we go. So this leads perfectly into the next example. Awesome. All right, here we go. So again, we're going to use this theorem, and I want you guys to find cosine of pi and sine of pi. Okay? Now, I have given you the angles in radians. Okay? We need to, if we want to think about it more concretely, we may want to just in our heads convert to degrees. Okay? So let me just write that. Recall that. Okay. Would someone like to tell me what pi radians corresponds to in degrees? Do we know that?
180.
180, yes. Thank you, Camille. Yeah, so pi radians is 180 degrees. Excellent. So the reason why I want to just think about it in degrees is because it makes it easier to draw the angle in standard position. All right, good. So unfortunately, I don't have an image for this. I'm going to have to draw it myself. So just bear with me. So I want to draw an XY axis. I want to draw a unit circle, and I want to draw 180 degrees. All right, so this is what I will attempt to do. All right, so here's my XY axis. Okay, here's my origin. I will draw a circle of radius 1. All right, that was okay, I guess. Now, I would like to now travel 180 degrees and see what point on the unit circle we get to. All right, so here we go. 180 degrees is like that. Okay, so that's 180. Let me just highlight it. So here is the 180 degree angle. Good, so it looks like we're corresponding to precisely this point on the unit circle. Good, and what point is this? What coordinate of the unit circle is this? Well, this is just going to be -1, 0. Okay, so does everyone agree that this leftmost coordinate on the unit circle is -1, 0? Okay, so I'm just going to scroll up quickly to my picture. Yeah, look, the left coordinate, yeah, it is -1, 0. All right, good, good. All right, so now we're done. So the x coordinate is what? -1. Okay, that means that will be our cosine. So cosine of pi will be -1. That's the theorem. You have to look at the x and y coordinate of where you intercept the unit circle. Good. So now we do the same thing for the y coordinate. Okay, good. So the y coordinate, which I'll just abbreviate to chord, is 0. And that's it. That will be your answer. It will be 0. So sine of pi is 0. All right. So here's the takeaway. All right. This is what.
If you were to substitute cosine sine by its trigonometric function, so for instance, cosine is opposite over adjacent, does the bottom part of the denominator have to be 1 in order for that value to be -1?
So if you want to do this from the definition, you would go into the second quadrant here, and you would draw a right triangle. This, I think, yeah. And then this would be 1. Yeah, and then you could use the Pythagorean theorem to get the hypotenuse. Wait, actually, could you use? Okay, no, actually, you know what? Never mind what I just said. So I don't know off the top of my head how you would use the definition opposite over hypotenuse or adjacent over hypotenuse to get cosine of 180 and sine of 180.
Okay.
Yeah, I'm not exactly sure. I can
Or
get
maybe,
about that.
or I might be saying the question wrong. But I think maybe what I would just want to know is like why does I mean, if there was a way you could like repeat why cosine corresponds to x and why sine corresponds to y.
Oh, okay. Okay, very good question. So this goes a little past the scope of this course, but in very quickly, if you have the coordinate pair, cosine theta, comma, sine theta, okay, this is your x value and this is your y value. Okay, this is a coordinate pair in the xy plane. If you let theta run, like you let it range from 0 to 2 pi. So look at this coordinate pair and see where it moves as you let theta run from 0 to 2 pi. This will actually trace out the unit circle. Okay, so this is a way to parameterize the unit circle. Okay, so this is something you look at in Calc 1 or Calc 2. Okay, so it's a little past the scope of this class, but that's essentially it, is that cosine theta, sine theta will parameterize the unit circle. Yeah, all right, so. Okay, good, good. All right, so we're gonna move on a little bit if that's, if no one has any questions. So please just let me know.
Could this happen with a 20 degree or something? Would this be weird?
Yes, so 20 degrees, this would work, absolutely. However, I don't know what coordinate on the unit circle 20 degrees will intercept. It will
Yeah,
be,
that's why I was curious.
yeah, so it'll be like right here. Something, it will look like it was right here, but there's no way for me to get at this coordinate right here. I have no idea what that would be. So really, this theorem is just useful for calculating these guys, the ones that live on the axis.
Thank you.
Okay.
There's one more thing before. Is there a reason why we use 1 to be the radius of a unit circle?
You know, I think it goes back to what I just said before. It's because the coordinate pair cosine theta comma sine theta, you let theta run from 0 to 2 pi, that will trace out precisely the unit circle.
Okay.
Like it doesn't trace out a circle of radius 2 or a different radius. So I think it goes back to that, what I just told you.
Okay.
Yeah, that's a good question. Yeah, I'm not like 100% sure on that. Okay, good. All right, good. So now we need to talk about the sign of trig functions. And when I say sign, I mean SIGN, not the trig function. So it's a little, I know it's a little weird. So we need to talk about the sign, SIGN, of the trig functions. In each quadrant. Nice. Okay, and when I say sign, S-I-G-N, I just mean, is it positive or negative? That's what sign means. Does it have a negative sign in front, or is it just positive with no sign in front? Okay, so this is how it works. So I have a picture here. Oh, okay. Okay. So here we have the XY plane. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? Now what's listed next to each quadrant, sine, cosine, tan, secant, cosecant, cotangent, these are the trig functions that are positive in quadrant 1. Okay, all of them, essentially, all of them, okay? Now, how about quadrant 2? The only trig functions that are positive in quadrant 2 are sine and cosecant. The rest will be negative. So what's listed next to the quadrant are the trig functions that are positive in this quadrant. That's how you read this. Okay, quadrant 3, tangent and cotangent will be positive. The rest will be negative. Quadrant 4, cosine and secant will be positive. The rest will be negative. Okay, good. So the way that I was kind of taught this, like an acronym, so you have all, then you have sine is positive, then you have tangent is positive, then you have cosecant is positive. So a way I was taught back in the day was you use the phrase all students take calculus. Okay, so all students take calculus. That'll help you remember which ones are positive in which quadrant. Okay, and I've had students come up with some other creative words to put in for C, but I'll leave that to you guys. I'll use calculus.
Do you encourage us to draw this?
You can definitely draw it if it's going to help you.
Or would it just look better to like refer back to the recording if we ever needed like a scale or like a graph?
Oh yeah, you can definitely look back on this if you want, for sure. Yeah, whatever you're comfortable with. Yeah, so this is going to tell you in which quadrant which trig functions are positive. So all in this quadrant, sine in this one, tangent in the third, and cosine in the fourth. So all students take calculus. Okay, good. So I'm just going to just type up quickly what I have here. All right. So use the phrase. Okay, good. So quadrant 1, we have all trig functions are positive. Okay, meaning if I take an angle that lives in the first quadrant, all of them evaluated at that angle will be positive. Okay, quadrant 2, sine is positive. Okay, actually sine and its reciprocal cosecant are positive. Rest are negative. Okay, quadrant 3, tan and cotangent are positive. Rest are negative. Last one. Cosine is positive. No, cosine and secant are positive. Rest are negative. Okay, so that's how so that's how it plays out, and you get this acronym, or this phrase rather, all students take calculus, just by looking at the first letters here. So we have A, S, T, C. All right, so that's how it plays out. All right, so we're gonna now use this. All right, so now let's kind of use this and let's practice with it. Okay, so here's an example. If theta is equal to 200 degrees, tell me which trig functions are positive and negative. Okay, so here is a direct application of what I have above. So we have the angle of 200 degrees. Tell me which trig functions will be positive and negative if I evaluate them at 200 degrees. All right, so I'm just going to draw an axis or a XY plane. Okay, now 200 degrees, that means if this is 180, that means 200 will be a little past 180. So it'll be about there. Okay, good. So now it's clear which quadrant we are in. So would anyone like to tell me how this plays out? Would someone like to answer this for me?
So tangent and cotangent are positive because they're in quadrant 3, and everything else is negative.
Excellent, excellent. So let me just start off by saying we are in the third quadrant. Very good. Thank you, Luke. Thus, okay, so now we just need to look at our quadrant 3. Okay, good. So we have this nice little diagram. I know that tangent and cotangent will be positive. Beautiful. Rest are negative. Excellent. Thus, okay, thus, right. So thus, tangent of theta and cotangent of theta are positive, and the rest are negative. Good, so just make note, when I say they're positive, it means that when I apply tangent to 200 degrees and when I apply cotangent to 200 degrees, the output of the functions will be a positive number. That's what it really means when I say that they're positive. It means their output will be positive. Okay, excellent. So any questions here? All right, we're going to do some more because this is actually very fundamental. So I actually want to just get a lot of practice with this. All right, let's do another one. So another example, it'll be same as before, but let's let theta be equal to 2 pi over 3 radians. Okay, so I want you to tell me which trig functions will be positive and which one will be negative. So what I would do here, just to make it easier to visualize this angle, I would convert this to degrees. That's what I would do. And then I will draw the angle and see what quadrant we're in. Okay. So let's kind of do that. So firstly, 2 pi over 3 radians. So you guys can use the conversion formula. What do? You multiply by 180 over pi. You will get that this is, what is this? 120 degrees, okay? Good. So once I know the angle in degrees, I can just draw it quickly to see what quadrant we're in. Okay, so if here is 90, that means I just need to travel 30 degrees out more to get to 120. So it's going to be here pretty much. It's going to look like it's over here. Good, good. So it should be clear that we're in quadrant 2, okay? All right, so please let me know if you disagree that we are in quadrant 2, or if you're confused as to why. All right, because this angle lands right here. This is quadrant 2. Good, so we're pretty much done. Now we just need to go up to our picture here and go to quadrant 2. Ah, okay, sine and cosecant are positive in quadrant 2. Very good. Thus, sine of theta and cosecant theta are positive, and rest are negative.
Professor Roberts, just in the just to be thorough and stuff, do you mind just doing the quick conversion from 2 pi over 3 to 120?
Definitely. Definitely. Okay, good. Yeah. So I do like to convert radians into degrees just for my own, just to make it easier to draw the angle. And so let's just talk about quickly how to do that. So what you do to get to from radians to degrees, you multiply by 180 over pi. So we're going to take 2 pi over 3, and we're going to multiply by 180 over pi. Okay. Good, good, good. So what happens here? Well, the pi's will definitely cancel. So we'll get 2 times 180 over 3. Okay, now you can factor 180 as 60 times 3. So in the numerator, this 180 can be written as a product of 60 and 3, but then the 3's will cancel. So you're left with 2 times 60, which is exactly 120. All right. So when you convert from radians to degrees and vice versa, you're going to need to simplify the fraction a little bit. And if you'd like to use a calculator for simplifying some of these fractions, but definitely go for it, because they can be a little lengthy or annoying sometimes. All right. So I hope that's good, Luke.
I have a quick question. I don't know if this is completely stupid, but I know that pi equals 180 degrees. And I noticed that if you plug in 180 and multiply that by 2, you get 360 over 3, which equals 120. Is that just a coincidence, or?
No, that's totally legit. You can do that too. You can literally just sub in one. So you're saying just substitute in 180 for pi right here?
Yeah.
Yes, that will work. You can always do that. Very good. Good insight. Okay, so I want to keep this in the notes, so I'm just gonna shrink it a little bit. Yeah, I'll put it up here. Okay, excellent, very good. All right, so let's do another example. So I know this maybe is a little boring, but trust me, this is very fundamental, and it will come in handy with some later stuff we do. So let's just kind of keep going here. Okay, so if theta is equal to 300 degrees, the question is secant of theta. Is secant of theta positive or negative? Okay, so let's all take a minute or two. Let's think about it, maybe do it on your own, and then I'll go over it, okay? Okay, so firstly, we need to know what quadrant we're in. So I will ask you guys that first. What quadrant? What quadrant are we in? 300 degrees, what quadrant does that land us in? So because remember, we need to know the quadrant to know what's positive or negative. So would someone like to tell me?
Fourth.
Fourth, excellent. So that's the first piece of data that we need. We are in the fourth, excellent. Well, now we need to just go up to our nice little picture here and see. Aha, in the fourth quadrant, cosine and secant are positive. And what we were asked about secant, weren't we? There we go. So secant is positive, excellent. So thus, by our picture above, we know that secant is positive in the fourth quadrant. Very good. So it really is as simple as that. Identify what quadrant you're in, and then just go and use that picture, or you can use that phrase, all students take calculus, or make up your own phrase. That's cool too. All right, very good. So now we're gonna move on. Yeah, no, okay, all right. So we're doing well here. All right, so now we're gonna move on to reference angles. Okay, reference angles. That's our next topic, and it will use this. We didn't just do this for no reason. It's going to use our work. So we very rarely just do things. I don't think we ever just do things just to do them. It's going to, we do things because they build upon each other. Okay, so let's see how this plays. Okay, reference angles. That's the next heading. Okay, so I'm going to define what a reference angle is. All right, so here comes the definition. Sorry. Okay, here we go. So firstly, let theta be an angle in standard position. Okay, so that's just an angle in the XY plane with its vertex at the origin. Okay, so here we go. Then its reference angle. So here comes the definition, so I'll underline it. Then its reference angle is defined to be. It's found to be the angle that theta makes with the part of the x-axis closest to it. Closest to it. Okay. All right, so I know this doesn't sound very precise. What do I mean by closest to it? Do I have a picture? I'm not sure. Hold on, let me see. No, I don't, unfortunately. Okay, so we're just gonna go with it. So basically, you're gonna be given an angle in standard position. So maybe like here. This will be our angle. So let's say we traveled out, I don't know, it actually doesn't matter. So we look at the part of the x-axis that's closest to the angle. Is it this part of the x-axis or is it this part of the x-axis? Well, it looks like it's closest to the negative part. So it's closest to here. So we look at the angle that this makes with the negative x-axis. So this will be the reference angle right here. Okay, not this one. It's going to be the angle over here. All right, so this will become clear with examples. So let's just jump straight to examples. All right, here we go. Find the reference angles for. So I'm just going to list like a bunch of angles, and we're going to find the reference angles for each. So find the reference angles for pi over 3, 135 degrees, 225 degrees, and negative pi over 6. So just notice I'm doing a nice healthy mix of radians and degrees, just so we're getting comfortable with both units. Okay. All right, good. Let's do pi over 3 first. Okay, so I'll just label this as A, pi over 3. Okay, firstly, we're going to need to draw these in standard position. And when I draw them in standard position, I like to convert to degrees. All right, I said this earlier. So pi over 3 will be 60 degrees. Okay, and as Jenny said, you could just substitute in 180 for pi and just do 180 divided by 3. That will give you 60. All right, so that's a way to quickly do it. To do it the old-fashioned way, just multiply by 180 over pi. All right, good. So let's draw this in standard position. So we're going to do 60 degrees. It's going to look something like this. Okay, this is 60 degrees. Good. So which part of the x-axis is closest to this angle? Is it the positive one, the positive side, or the negative side? Well, it's the positive side. So we just have to look at the angle that this makes with the positive x-axis. Well, it is just going to be itself. It is 60 degrees. All right.
Does the reference angle always have to be positive?
I'm sorry, I wasn't able to hear you that well.
Does the reference angle always have to be positive?
No, it does not. We're going to use them positive, but no, it doesn't. Reason being is because you can subtract 360 degrees from any angle, and it will kind of stay the same. That's like the coterminal thing from the homework. So if you have a reference angle of 60, you can subtract 360 from it, and it will still be the same. But we're just going to keep them positive, though. All right, so the reference angle here is 60 degrees. All right, so like we see that if we have an angle that lives in the first quadrant, its reference angle will be itself, and that's always going to be the case. Okay? All right, next. What's our next one? All right, we're gonna do 135 degrees. Okay. Good, this is already in degrees, so let me draw it in a standard position. All right, 135 is gonna land us in like the second quadrant. This is 135. Good. Now we need to calculate the angle that this makes with the part of the x-axis that's closest to it. Is the negative x-axis closest to it, or is the positive x-axis closest to it? Well, it should be clear it is the negative x-axis that we're going to be using. Okay. So what will this angle be right here? Does anyone see a way we could get this angle?
Would you subtract 180 from it?
Extremely close. I think you meant to say subtract 135 from 180.
Yes.
Yes, that's exactly it. So this angle, the highlighter, the highlighted angle, that's 180. How can I get this missing piece? Well, just do 180 minus 135. Very good.
Just out of curiosity, why wouldn't you do 360?
360. Well, if I have this angle as 180, and I have this 135, if I kind of take out 135 from the 180, I'm going to be left with precisely this. If I subtracted 360 minus 135, you would be like over here. It's the wrong angle. Yeah. So you do 180 minus 135, and what is that? Well, that's easy. That's just 45 degrees. Good. So the reference angle is 45. All right, so I hope everyone sees. So I actually have a nice set of steps on how to determine the reference angle, depending on which quadrant it's in. That's going to come after these examples. All right, so I will have a procedure or set of steps. So like just in case you don't really see how it's 180 minus 135. I will have a set of steps for you guys. All right, let's do the next one. The next one will be 225. Good. So I draw my XY axis. I'm going to draw the angle in standard position. So if this is 180 and this is 270, that means that 225 ought to be in the third quadrant. So it's going to look like this. Wow, that was a bad one. Okay. There we go. So something like that. So that will be 225. Okay, good. So now we see what part of the x-axis is closest to this angle. Is it the negative part or the positive part? Well, it looks like it's closer to the negative part. So we need to look at the angle that this will make with the negative x-axis. So we're looking at for this angle right here. All right, so does anyone see how we could get this angle similarly to how we did it up here? Does anyone like kind of see the calculation?
Could you do 270 minus 225?
Close.
I'll give you
Close. We don't want 270 because 270 is this angle here.
225 minus 180.
Yes, that will be it, exactly. So we want to get just this little portion right here. So you do the full amount, which is 225, and then just slice out 180. So we take the full amount and we slice out this part. And we're left with just precisely that. Okay.
For now, why do we keep the reference angle positive? I mean, I know it's not a big thing, but just curious.
It doesn't need to be positive. It's just, it doesn't need to be positive. It can be negative. So like, as I said, if you subtract 360 from an angle, it will turn it negative. Well, at least where we are. So that will represent the same angle, but it will be negative. So yes, it can be negative, but for our purposes, it's just a little simpler to keep them positive.
Okay. Gotcha.
We like to work with angles that are between 0 and 360 or 0 and 2 pi. We like to stay in that kind of positive interval there.
Gotcha.
Yeah, but we'll do some negative angles though. Okay. Good. So we do a 225 minus 180. Excellent. And what is this? Right. So this will be 45 degrees. Very good. Do we have another? Yeah. Okay, last one. We have negative pi over 6. Was that the last one? Yes, negative pi over 6. Okay, good. So I like to convert to degrees, just quickly. So you do the conversion to degrees, you'll get negative 30 degrees. Okay, good. So now let's draw this in the standard position. So I have a negative sign here. That means I need to not travel counterclockwise, I need to travel clockwise. That's what the negative sign tells us. So I start here and I travel 30 degrees in the clockwise direction. So it's going to be right here. Okay, good. So what part of the x-axis is closest to my angle? Is it the negative side or the positive side? Well, it looks like it's going to be the positive side. That's definitely closer. So we just need to measure this angle. Okay. You measure this angle. So what you do, it's just going to be 30 degrees. Okay. So you measure this angle, but you take the positive orientation of it. Yeah. So this will be 30 degrees. Okay, good. So we kind of did this like in our heads, but I do have a nice set of steps you can follow given some angle, how to find its reference angle, okay? So alternatively, one can use the following formulas. To find a reference angle. Okay, so let me just go to that. I think I have it in a picture. Yes, very good. Okay, let's see. All right, so let me just kind of talk through these. We actually did an example of each. We did one in each of the 4 quadrants. Okay, so hopefully you guys can read this. I hope it's not too small on your screen. I can't really make it that much bigger. I don't know why. Okay, so 1, an angle in the first quadrant is its own reference angle. We did that. All right, that was example 1. Next, for an angle in the second or third quadrant, you do 180 minus t, take its absolute value, or do pi minus t if you're given radians. Okay. For an angle in the fourth quadrant, you will do 360 minus t, or 2 pi minus t, depending if you're in radians or degrees. And now, if your angle is outside of the 0 to 2 pi range, you need to find an angle that's coterminal to it in between 0 and 2 pi, and then use either 1, 2, or 3 above. So this is in the homework and it's in the video I posted, finding angles that are coterminal to each other. So if an angle is less than 0 or greater than 2 pi, add or subtract 2 pi as many times needed to find an equivalent angle between 0 and 2 pi. All right, so these steps will work regardless. All right, so this will work. So any questions about what we did?
Kind of, since, oh, you already answered. Forget about it. It's already.
You sure? Okay. Okay. Good, good. All right, so here is kind of like, so what's next is kind of the culmination of all of our efforts. Knowing which trig functions are positive in which quadrant and reference angles. Now we're going to put it together to do some really nice stuff. So here's the next heading. Using reference angles to evaluate trig functions. Okay, so I just have a quick thing that I would like to type, and then we'll move on. So it turns out we can use the values of the trig functions in the first quadrant, that is angles between 0 and 90 degrees, to find their values in the other quadrant. Okay, so if we want to find like cosine or sine of some angles that are in the second, third, and fourth quadrant, it turns out we just need to know their values in the first quadrant. okay, which we know already. Okay, we have done sine and cosine of 0, 30, 60, 45, and 90. So we've already have discovered some values in the first quadrant, okay? And now we're going to use those values to get at the other quadrants. And the link are the reference angles and the positivity or negativity of the functions in the quadrants. All right, so it comes together very nicely. Okay, good. So I need to summarize all of our values so far. Okay, so here's a trig table. I know this looks a little overwhelming, but this is really everything that we've done already. That tells us our cosine, sine, and the rest of our trig functions evaluated at each of the special angles. Okay, so for instance, cosine of 0 is 1, cosine of 30 degrees is rad 3 over 2, and so on and so forth. All right, so hopefully you guys know how to read this table. There really is nothing new here. We have done everything on this table. I know we didn't do like tangent, secant, cosecant, cotangent, but these are just some sort of reciprocal of the first three, okay? Because remember, secant, cosecant, cotangent, those are the reciprocal functions of cosine, sine, and tangent. All right, so we actually have done everything in this table. I know it doesn't seem like it. So any questions about how to read this table? So this just tells me the trig functions evaluated at our special angles. So this will become useful. You definitely do not need to memorize this, but it will be a good reference. Okay. All right, good. So here we go. Here we go. So what we're going to be doing is how to find the value of a trig function that is not in the first quadrant. Okay, so look at our angles here in the table: 0, pi over 6, pi over 4, pi over 3, and pi over 2. These are all in the first quadrant. So we're taken care of in the first quadrant. Okay, we're done. We have discovered really everything that we want to know about the first quadrant. But now we're going to find out how to do things in the second, third, and fourth quadrant. Okay, so here are the steps, and they're really not that bad. Step 1. Find the reference angle, which we know how to do. Step 2. Evaluate the trig function at the reference angle. Okay. Okay, step 3. Determine whether the trig function is positive or negative based on which quadrant we're in. Okay, so step 3 has to do with that all students take calculus phrase. Based on which quadrant we're in, tell me, are we positive or negative? All right, step 4. If negative, negate your answer from step 2. If positive, leave your answer alone from step 2. This is your final answer. So this is all stuff that we know how to do, okay? And that was kind of the point of the first part of lecture today, was to kind of build up our tools so we can do steps 1 and 3. All right, so we're gonna now do some practice with this procedure, and that's gonna be the end of class. All right, so I think I have like 3 or 4 example problems. All right, so these steps that I wrote out, they will become very clear once we do examples. All right. All right, so here we go. Here we go. So this is, I think, kind of fun. So example, find cosine of 150 degrees. Okay, so I'm going to number the steps as they correspond to the steps that I wrote out up here. So 1, we're going to find the reference angle. So here we go. So 1, find the reference angle. Good, so 150 degrees. So we need to figure out the reference angle for 150 degrees. So 150 degrees is going to land us in the second quadrant. It's going to be like something over here. And we would like to find this angle right here, the angle it makes with the negative x-axis, okay? That's the part of the x-axis closest to 150 degrees. Good, okay, so good, so the reference angle is, okay, so what do we do for this one? We're gonna wanna do 180 minus 150. That's how we're gonna get at this angle. Is 180 minus 150, which is 30 degrees. That's step 1. Yes, 30 degrees, very good. Okay, that's step 1. I think that's like the hardest step, honestly, because the rest are relatively simple. So what's 2? Evaluate the trig function at the reference angle. Very good. So we're going to evaluate now cosine of 30 degrees. You evaluate your trig function at the reference angle. Very good. And what is so beautiful about this is that we have a value for cosine of 30. And how do we get that? Just go up to your table here. Totally fine. Use this table. So we go to the cosine row, and then we just move to the 30-degree column. There it is. It's radical 3 over 2. Done. Okay. Use the table. Use the table. It will be radical 3 over 2. Excellent. Okay, now step 3. Determine whether the trig function is positive or negative based on which quadrant we're in. Okay, what quadrant are we in, folks? We are in the second quadrant. We are in the second quadrant. Okay, now what's our trig function in question? It's cosine. Is cosine positive or negative in the second quadrant? That's the question we must ask ourselves. Okay, so you use that phrase, I'll think of all students. So sine is positive in the second quadrant, so cosine's negative. Cosine is negative in the second quadrant. All right, so does everyone agree with me? We're in quadrant 2. Use that picture from earlier that listed the positive trig functions in each quadrant. Sine is positive in quadrant 2. So cosine will be negative. All right, and now we're pretty much done. Step 4, if negative, you negate your answer from step 2. Well, our answer in step 2 is radical 3 over 2. So just negate it, put a minus sign in front of it. So we're done. Negative square root of 3 over 2. So that's the negation of our answer from step 2. Okay, so that is the process. So any questions on the procedure?
What do you mean when you say negation?
Negation is simply the result after multiplying your number by -1. So multiply radical 3 over 2 by -1, you will get negative radical 3 over 2. Okay, and that's it. That will be our answer. It is negative radical 3 over 2. So it actually comes out to be very nice. All right, let's move on. I want to get these done and try and finish a little early. Okay, find. We're going to do the same thing. We're going to do sine of 150 degrees. Okay, so step 1, we need to find our reference angle. Well, we found the reference angle for 150 already. It is 30 degrees. Good, step 1. The reference angle is 150 degrees. Good, so this was just from earlier. That's the previous example. Step 2, you evaluate, excuse me, it's not 150. The reference angle is 30 degrees, of course. My bad. Reference angle is 30. Good. Okay, now we evaluate our trig function at the reference angle. So you evaluate sine of 30 degrees. Good, so use the table. Sine of 30 degrees. So this is just so excellent. We have a value for sine of 30. So let me just scroll up to my table, go to the sine row, and then travel out to 30 degrees. It's 1/2. 1/2. Saeed, would you mind just muting your mic, man? Thank you. Good. Now we need to make note of which quadrant we are in. So it's the same as before. We are in quadrant 2. And as stated earlier, the sine function is positive in quadrant 2, where sine is positive. Where sine is positive. Good. So if we're positive, you literally just leave your answer from step 2 alone. So the answer is 1/2. Thus, sine of 150 degrees is just positive 1/2. So since sine is positive in the second quadrant, you look up to our set of steps. That means we're just going to leave our answer alone from step 2. All right, so we're just keeping this 1/2. That's really all there is to it. That is the process. It's not going to change. This is it. Good. So I have some more examples. How many more? Yeah, I have 3 more examples. All right. I know it seems like a lot, but this is very important. All right. And if anyone decides to take Calculus 1, it will be very good to have this down. All right. So we're going to now do find cosine of 5 pi over 4. All right, so the difference here is that my angle is given in radians, all right? I like to switch it up a little bit. I don't just want to stay in degrees, all right? We need to kind of step out of our comfort zone a little bit because radians are more common when you go into upper level mathematics, okay? So we need to apply the set of steps. So firstly, I just like to convert to degrees. All right, it just makes me have a better handle on these things. So you do this, you do the conversion. I'll leave it to you guys. You can use a calculator. This will be 225 degrees. All right. So just do the conversion formula from radians to degrees. Good. All right, step 1, reference angle. Here we go. So where are we at in 225? Well, we're going to be in like the 3rd quadrant. So it's going to look something like this. Good. So we need to look at the angle that it makes with the part of the x-axis that's closest. Well, the closest part will be the negative. So we're looking for this angle right here. Good. So the reference angle is, so what you do in this one, you're going to do 225 minus 180. Okay. Which is 45 degrees. Very good. That's our reference angle. Step 2, we evaluate the trig function at the reference angle. So you evaluate now, what are we doing, cosine? Yes, you evaluate cosine now of the reference angle. Very good. Again, use the table. Cosine of 45 degrees. All right, so you can scroll up, or you can look up. You can look up in your notes. Cosine of 45 degrees is square root of 2 over 2. Okay. That's the second step. Third step, we have to see if our function is positive or negative based on which quadrant we're in. All right, so we're in what? We're in quadrant 3, where, so we're doing cosine, where cosine is what? Okay, so we're in quadrant 3. All students take tangent is positive in quadrant 3. All the rest of them are negative, so cosine will be negative. Okay, the only trig function that's positive in quadrant 3 is tangent and cotangent. Cosine will be negative. All right, now we're done. Since it's negative, we need to negate our answer from step 2. So negate your answer from step 2. It is negative radical 2 over 2. You're done. Thus, cosine of 5 pi over 4 is exactly that, negative radical 2 over 2. All righty. Okay, so any questions? Okay, so I have a few more examples. I'm going to move through them a lot quicker. I'm not going to do this step 1, 2, 3, and 4 kind of layout. I'm just going to move through them quicker just in the interest of time. So please let me know if you have any questions. Okay. Right. All right, good. So we're going to now do find sine of 5 pi over 4. Okay, so I'm just going to go straight to it. So firstly, the reference angle is 45 degrees. So this is the same angle that we just did, right? Yeah. So you can just use your data from the previous question. Reference angle is 45 degrees, and we are in quadrant 3, where sine is negative. Okay, so we have all of the data that we need. So sine of 5 pi over 4 will equal negative sine of 45 degrees, which is negative root 2 over 2. Okay, so where did this negative sign come from? That came precisely because sine is negative in quadrant 3. So I've kind of combined steps 1, 2, and 3 into literally one equation, into one chain of equal signs. All right, so I'm going to do the last two examples in this fashion. All right, just to move a little quicker. All right, so is everyone okay? Please let me know. So I still am following the set of steps I outlined, but I'm just doing it in a quicker way. All right, good. Let's do a more exotic trig function. Let's do secant. Let's find secant of 7 pi over 6. Okay, so what I like to do, I like to convert to degrees just so I can kind of get a mental picture of where we're at. What quadrant are we in? So first, that's just my personal first step. So first, 7 pi over 6, convert this to degrees. You use your formula. This will be, you can check me on this, this will be 210 degrees. Okay, good. So now let's find the reference angle. I'm going to do it quickly. So the reference angle is, it's going to be 210 minus 180. Okay, which is 30 degrees. Very good. And so now what quadrant are we in? We are in, so 210 degrees is in quadrant 3, okay? And we are in quadrant 3 where okay, so in quadrant 3, tangent is positive. Tangent is positive. Thus, secant will be negative. All right, so here we go. So now we're pretty much done. Thus, secant of 7 pi over 6 will equal negative secant of the reference angle, negative secant of 30. This will be, now recall what secant is. Well, actually, we don't even need to do that. We can use our table. So it will be negative. Now I'm going to scroll up to what secant of 30 is. Okay, I go to the secant row, travel to 30 degrees, 2 rad 3 over 3. Beautiful, beautiful. So the answer will be negative 2 rad 3 over 3. Okay, so from this step to this step, this is from the trig table. So that is very useful from the trig table. All right, so this was very fast. So please stop me or ask me questions. All right. You get a lot of practice on this in the homework too. The last question on the homework is like 9 of these, or 8 or 9 of these types of questions. You're gonna get a lot of practice with this. All right, we have one last example. All right, last one. Let's find secant of 300 degrees. All right, very good. So the reference angle, so you guys can check me on all this. The reference angle is 60 degrees. Okay, so 300 degrees will make an angle of 60 degrees with the positive x-axis. Good. What quadrant are we in? We are in quadrant 4. 300 degrees lands us in the 4th quadrant. We're in quadrant 4 where cosine is positive, and thus secant is also positive. Okay, why is secant positive? I know that cosine is positive in quadrant 4. So why is secant positive? Other than just looking at our picture from earlier. Does anyone know why secant, why cosine being positive will imply that secant is positive? What's the connection between the two?
They're reciprocals.
Excellent. Yes. So if a number is positive, then so will its reciprocal. So if cosine is positive, then its flip, its reciprocal, will stay positive. Excellent. Very good intuition. All right, good. So that's it. We have all of our data. We need the sign, positive or negative, and we need the reference angle. Good. So we're in the home stretch. Thus, secant of 300 degrees will equal positive secant of 60 degrees. Since it's positive, I don't need to put a minus sign here. Good. And now you go up to the table, this lovely trig table, secant of 60. All right, so I go to the secant row, and I travel to the 60-degree column. It's 2. Very nice. 2 from the table. So as I said, all of our work in the first quadrant has now opened up the second, third, and fourth quadrants to us.